Now you see we're getting the full multimedia experience this week. We've got sound in the pocket, we've got video over here. Oh my God. Right. We'll let you get resettled and comfortable before we start. We'll try and make this interactive. Those of you who have laptops out, you've got to calculate that. That might be very useful. Because you want to be able to start to shout. Right. Thank you. And still they come in. There we go. There are no, just a warning, there are no slides on this, okay, so what you see on the board is what you're going to get. You want to take notes, please.
WYSIWYG things.
One of these absolutely, WYSIWYG, my God, there's a word I haven't heard from anyone yet, WYSIWYG, okay. I set that exercise without doing the lecture first, quite deliberately, because it's kind of an integrative thing, and it uses lots of different lots of different concepts from the course that we've seen so far. And I really wanted to let you have a go at it yourselves first, and see what you made of it before I dived in there. One or two have done it, not successfully, one or two have had problems, but let's kind of look at some of the basic underlying concepts, and then I'll say a bit about how I might tackle it, and how I've seen other people tackle it as we go. First of all, why are we worried about checksums? Why do we care about checksums? And what are they? Does anybody want to tell me what a checksum is and what it's for?
Well, we're making sure that files transferred without any errors.
Pretty much. It's actually slightly more general than that. It's basically a way of saying, is there any error in this data? Has it been copied correctly? Has it been transferred correctly? It's not just about files. It's about taking some data from one place, moving it to another place and saying, is it still okay? Now the basic idea is that we're going to treat the data, whatever the data is, simply as a list of numbers. Okay, so here's some data, and I'm going to say that it's actually the word hello, which we want to transfer via a network connection, perhaps. Now, as you can see, it's a long way from there to here, so quite clearly there could be some error introduced in the transmission between there and there. So what we're going to do is we're going to add an extra bit of data on the end, which is going to help us somehow test whether what's over there is a good copy of what's here. Now what I need to do is, instead of treating these as characters, is to treat them as numbers. Now I'm hoping somebody out there has either a better memory than I have, or quick access to the ASCII table. Because what I'd like to do, we can think of this data as being letters, but actually the computer really holds it as binary. I've seen in the labs people asking me, well, how do I convert this from binary to character and binary to decimal? Wrong way of thinking about it. What's actually in there is binary. Okay? Now, can anybody tell me what the ASCII code for H is? Lowercase. You laptops and wireless connections. Anybody have a look at the ASCII character table and give me the number for H? So it'll be around
72. Capital H.
Oh, well, okay, alright, well, we'll make it easy. 72.
H is 104.
104. I did at one point. While you're on, you can be looking up the others. Can anybody see what I've done for border? I did have that. No, that was okay, 104 E, 101. 101 L, 108. And 101. So the idea behind a checksum is actually very easy. The clue is in the name. It's a sum that we use for checking things. What we're going to do is to sum those values. We're going to add them up. But the catch is, we're going to do it modulo 255. Now that basically means exactly the same as we saw earlier on in the class. We're going to treat each one of these as bytes, and we're going to treat our sum also as a byte. So in other words, it's going to be 8 bits long maximum. So if we add these two up, or we add these things up and we get something over 255, it's going to wrap round again to 0 and start up again. So we're going to do some arithmetic here, and I'm rather hoping that you guys are going to do this for me. So we're going to start out, and I'll tell you guys to put some byte here, so we'll start it equals to 0. So the first thing we're going to say is that the sum equals the sum plus 104. So fairly obviously, it's 104. Okay. Then we're going to add the next one, which is 101. So 104 plus 101 is 5. Right? 205 plus 108 is 313. Alright. Now unfortunately that's bigger than 255. Okay, so that's not going to happen. What's actually going to happen is that it's going to wrap round. So how much bigger than 255 is that? 58. So what you're actually going to get for the next one is 58, because it's only a byte. So we keep going. 58 plus 108. 1.66. I'm glad that some of you can do their mental arithmetic here. May I say that it's always the more mature students who can do the mental arithmetic, and these guys go, where's the calculator? Sadly, I'm in the where's the calculator brigade. Well done. Right, and finally, 166 plus 111, 277, which unfortunately is bigger than 255, so we take 255 off that and we get
20.
Okay. So that is what happens if you sum all of these values modulo 255. You get the magic figure 26. Now, to generate a checksum, the idea behind putting a checksum value in here is that we want, if we add all of these and the checksum, it should give the answer 0. Okay? So if you like, the sum plus the checksum needs to be forced to be equal to 0. What value can you add to 22 which will give you 0? Minus 22. Splendid. So in other words, if I were in this special position over here, put the value minus 22 and add them up, then the new sum would be 0. So what we're going to say is we're going to use minus 22 as our checksum. Okay? So what we do is we send our data over to the far side. So somehow by file transfer, or maybe we're saving a file to disk or whatever, we send the numbers over here. 104, 101, 108, 108, 101, right. We've got a new copy of our data, whether it's a file or whether it's a data packet that's being sent over there, we've got a new copy of it. We want to now do the test to see whether it's being transferred correctly. So none of what we've done over there is about actually sending anything anywhere. All of it is about providing the means to do this test over here. So what we're going to do is add them all up. Now I could do it again on the board, but hopefully you're going to see I have that, and that, and that, and that, and that, and that. We're going to get zeros. The test is so if the value of adding all of those up is equal to 0, then it's a good copy. Else, something bad. Now let's just suppose that what's happening over here is that these are being sent over as binaries, which they are. Okay, whether we're saving it to disk or we're sending it on the network, what's actually travelling over here is a stream of ones and zeros going in that direction. Actually, it would be as a train of voltage pulses being sent to this direction. Let's just suppose that there was a cause of error. Yeah. Do my best Harry Potter impression. Okay, there's a lightning strike onto our hard disk drive or whatever as this stuff's going over, and actually one of those zeros, one of those one, oh shit, it's a projection screen. Is it? No, no, no. It's just a crap pen. Okay. One of those zeros. I have done that before. What you then do is swear the class to silence. Excuse my French. Right. So one of the ones has been accidentally changed to a 0. What will happen over here? Well, let's just imagine that HEL, the one that was affected, was actually the last bit of one of the L characters which being sent over here, and instead of that number being 108, it was 109. Okay? What's going to happen when you add all of that lot up? You're not going to get 0, you're going to get 1, or something other than 0. So if you get 0 over here, it's a good copy. If you get anything else, it's a bad copy. Now this isn't a terribly sophisticated checksum scheme. There are various different ways of doing it. And you can imagine that if by accident one of these ones became a 0, you could have a counterbalancing one where a 0 became 1 and you wouldn't be able to see it. But actually the chances of that are fairly small. It's got to be in a certain position. 0, good, 1, bad. Okay? That far, does that make some sense? This is why we do checksums. Okay? Right. The other thing that I've got to talk to you about is how you might try and implement this kind of thing. Now, let me just consult my notes, because there was an order I was going to do with this kind of thing. So, important things to notice first is that the size of your sum over here is 1 byte. The size of your checksum is 1 byte, because we were dealing with byte data. Each character was represented as byte. So keep all of those things as bytes. Don't change them to integers or anything like that. That will allow you to do good and proper. The marvellous thing about this is remember that you add them up to get the sum,